Hello, and welcome to today's webinar, Why Containerization Makes Sense for Your CMS. We really appreciate you taking time out of your busy schedule to join us today for this webinar. First, the agenda and just a few housekeeping items. We'll take about 2 or 3 minutes for the introductions, followed by 35 to 40 minutes for the presentations. Finally, we'll wrap everything up with 10 to 15 minutes of Q&A. And you can submit your questions directly throughout the webinar by using the chat window on your screen. Also, please follow this conversation live on Twitter using the hashtag ContainersWebinar. Just a little bit about dotCMS. We're an enterprise-level Java-based content orchestration hub which allows our customers to create, deliver, and manage memorable customer experiences. Our software is used by Fortune 500 companies and agencies alike in order to rapidly scale content-driven applications. And you can learn more about us by visiting our website, dotCMS.com. And we're really excited to have premier Docker consulting partner BoxBoat join us today for this webinar. They're going to tell you a little bit more about their company, but you can also learn more about them by going directly to their website at BoxBoat.com. Well, I'll be your moderator today, and my name is Robert Slaughter, and I'm the CMO here at dotCMS. Also today presenting will be Will Kynard, CTO at BoxBoat, and Brent Griffin, Senior DevOps Engineer at dotCMS. So with that, let's get to the show. First, I'd like to introduce you to Will Kynard, CTO of BoxBoat. Take it away, Will.
Thanks, Rob. So as he said, my name is Will Kynard. I'm the CTO of BoxBoat Technologies. We're based out of Washington, D.C., but we're spread mainly across the East Coast. We do work as far up as the Northeast, all the way down to Florida. We go pretty far west at times, but we have really concentrated on this container business, DevOps business, and we've found a lot of traction with enterprises heading that direction. So our go-forward business model, as you can see, is really around containerization. We were founded just a little bit close to 2 years ago, really around this whole idea that enterprises and companies are looking for a new way to speed up their development processes, to become more efficient in releasing code and bringing best practices to the table when it comes to continuous integration. And certainly as this whole new emerging technology movement with Docker and containers is changing the way that shops are doing everything from deployment, delivery, and integration, that's certainly a major part of the work that we do. So we are a Docker Inc. certified consulting partner. We do a lot of work for them. We do a lot of work for other shops as well. We do concentrate on Docker Inc. business, but we work within a series of these ecosystem technologies. We do a lot with Kubernetes and OpenShift as well. So a little bit about myself. I spent a lot of time as a web developer and a back-end developer and working for startups and kind of making the circuit. Somehow I found myself in DC working for venture capital and actually had the opportunity to begin investing in this type of emerging market with distributed technologies and developed relationships with a lot of these startups, one of them namely Docker, and I'm very, very excited to be working with enterprises to bring this technology to their practices. So today we're going to really concentrate on more of an introduction, what Docker containers are, or containers in general, how they can benefit your organization, and there are many ways to do that, and that could be a very long conversation in and of itself, and then focus on a use case, a customer use case that has brought a lot of value to them. So what is the Docker project? And this is really where everything began. Docker is an open source project. It is available at GitHub. I have a couple links here. Docker itself has been redoing some of these repositories lately, so you'll see a couple links, and there's some reasons for that. But when Docker was released to the public in 2013, it immediately became one of the most popular, if not the most popular, open source projects on GitHub to date. It's extremely active. There are many contributors, as you see, tons of stars and forks. If you go out there, they've reorganized some of these repositories, some of those stars and forks have been split up, but extremely popular. If you look at the graph to the right, this is Docker pulls from their central image repository called Docker Hub. It's up and to the right, right? So it's extremely popular. This technology is only growing in awareness, and especially lately in enterprise awareness. So what is a Docker container exactly, or even just a container? There's some deeper roots to this, deeper technological roots that we'll get into in the next slide. But put quite simply, it's a method to run an application in isolation. And normally when we talk about containers, it is from the Linux perspective, although that is quickly traversed into the Microsoft Windows world. But it is a new type of virtualization. But it's not virtualization itself, at least not traditionally as we think of type 1 and type 2 hypervisors. It's quite simply just an isolation or almost a sandboxing of a process on an operating system. So there's some fancy words here and constraints when it comes to C groups and namespacing to make that happen. But it is just an isolation of a process. That process within the Docker framework also comes with its own file system, which makes things very portable, very scalable, and very quick to start up. And you'll see a lot of these use cases as I go forward here. And as I'm going to talk about in this next slide, these technologies aren't old. The implementation is, the container technology isn't new. Its implementation simply is. So if we look back at some of the roots of containerization and how it's been brought to the forefront, I don't need to go through all of these, but quickly you can see a date here all the way down to 79, and some of the, with CH rooting, and then as we move our way up to jails, there were a lot of open source groups that contributed to, really formalizing the containerization process. So you didn't have to be a sysadmin to make it work. Google contributed a lot to it, and eventually it rolled up to a company that was called themselves .cloud out of Paris. This was led by a guy named Solomon Heights, and he is actually the one that created the Docker project, and it just rolled up all these technologies that I have listed here under a single platform that was easy for an end user to use. Once he introduced that to GitHub, it quickly became the most popular project, and he renamed his company to Docker Inc. So that's what we see today, and that's where the project initially came out of. Containers are not virtual machines. I like to lead off with this, especially because it's quick and easy to make comparisons, but they're certainly not. Containerization is a type of virtualization, but certainly not as we see that virtual machines perform with hypervisors. If you see on the left, a virtual machine actually encompasses an entire operating system, right? So we have the kernel, we have a file system, we have everything that operating system needs to run, and we're virtualizing the underlying infrastructure, as we see here on the left. Containers, however, actually run within the host operating system itself. So it's just almost sandboxing the processes with its own file system on the host operating system. So all of these processes actually use the same kernel. Now, what is the, why are we doing this? Why not just stick with virtualization? Well, containers no longer need, or if you're using containers, you no longer need to include an entire operating system. So with virtual machines, right, if we want to transport those, the portability, the scalability, you're looking at transporting the entire disk, the entire operating system. Containers no longer need that. So they can now be very small. They can now be very quick. You can run many of them at the same time, and you can scale them very quickly. They also become very portable. And because they share the same kernel, they will be using, right, the same underlying root user or kernel root binaries. However, it still is isolated within the container constructs itself. So I just want to get this out of the way. It's good to understand some of these concepts. Another point of confusion is that they are not mutually exclusive. So some like to say that, oh, well, you know, if we're going with containers, we're not going with VMs, and that's absolutely not true. Actually, the majority, if not all, of our installations that BoxBoat's performed in the last couple of years is on virtual machines. Virtual machines still bring the operating system to the table and management of that. Containers can now take benefit of scaling within, vertically within that single machine. So on to some of the use cases. There are many use cases. I've pulled out some major ones here and want to go through a few of these for us today. One of them is application development. I start with that one because this is really where containerization got its roots and grew out of. Containerization makes it very easy to recreate the exact same environment over and over very quickly. In comparison to virtual machines, it would be like running the fresh VM over and over and over again, but that's not very efficient, right? It takes a long time to boot a virtual machine, and if you wanted to run that every time you want to, say, test your code or you know, share with a friend, it's just not very feasible, right? We're not going to pass around a VM disk, although, you know, people have done that in the past. But from an application development perspective, we can now mount in our code to a container that has a set operating system. It's already pre-baked with our application binaries if we want it to be. And it's very quick to spin up. We're talking sub-seconds for the container to mount its file system and copy its binaries into memory. And now we can, say, develop code within a container that can be recreated over and over and over again from a new, fresh state very quickly. We can also now share with others. And it also implements some of these other constructs where we can now, as you see on the bottom, we can now do things like encrypting our container with a known private key, and then when we share with others or we deploy that out to our production system, we can know that that single artifact came from that developer. Developers love this. They love it because they're getting faster feedback from their code. They're getting faster feedback from QA. You're not getting as much artifact creep because everything is stored in that container. When we're pushing a single container through our continuous integration process, it is just a single artifact, right? We're not having to push all of our static images and static content to a separate versioning system and then keeping up with the final build binary as it makes it all the way through. We're now just keeping up with that single container image. This has been really, really great for developers. And it's really been a boon for automation and a boon for environment recreation. When we come to app modernization, this has also been a very key component to, you know, what we call this whole quote unquote microservice architecture and the whole microservices movement that a lot of shops are moving to. It's kind of a recreation of SOA or service-oriented architecture from a decade ago, but it has a new life now with containerization. This whole idea of microservices is that instead of building, you know, a vertical tier application or monolith, single binary or two that encompasses all of our application logic, we now split those across multiple services, actual multiple independent binaries. Without containerization, this would be pretty hard to keep up with. But now that we have these constructs where we can spin up services by themselves very quickly, and certainly the organization of those services, it's no longer overwhelming because we have versioning systems and we have a platform like Docker that keeps up with those. It's a boon for the microservice development. And what this allows the developer and the development team, the architecture of this application, when you have multiple services split up, is that you can independently update or upgrade each service without affecting the rest of the entire application. So before, if you wanted to make, you know, a single design change or a single logic change, you'd have to redeploy your entire app. If you break down that app, say, into 20 or 30 services, you're just making a single change to that service. And containerization And the Docker framework provides a very great construct for how to do that within versioning. Things like rolling up upgrades, rolling updates, blue-green deployments, and then even getting into replication and scaling. Now, if we create a cluster of Docker machines, we can now scale our services, and so we can create replicas of a single service. So if, say, our front end is getting hit more than other components of our application, we can just scale that one component. This is great for operations. And then getting into operations, right? We talk about inefficiency of VMs. Certainly, VMs brought a lot to the table over just running bare metal. There's a big reason why we've all adopted them. Because we needed more portability, we needed more management, we needed more scale, and VMs brought that to the table. But when we look at it in comparison to containerization, we kind of start asking the question, why are we having to recreate an entire operating system? Well, we do that right now because we need isolation for our workloads. With containerization, we're brought the isolation. We still have the isolation, so we no longer need this recreation of the underlying operating system. VMs, if we want to start our application that's in a VM, obviously we have to let the kernel boot up. There's boot time. There's a lot of storage there. There's licensing and hypervisor costs. With containers, we can still run these on VMs, or you can run them on bare metal. We have consolidated storage mechanisms. Containers are very small. So a container image, say, could be within a few hundred megabytes all the way down to 20 megs, depending on what you're doing. If it's an older application, it might be a little bigger. But this is extremely small in comparison to what we're used to working with virtual machine and their mounted disks. We also have much more flexibility when it comes to high availability and scaling as well. So if we need more of a single service, we just ask the Docker platform or whatever orchestrator you're on to give us more. And it's very quick to create containers, so we can create and scale a single service within a couple seconds, say from 1 container to 10 containers that are now all servicing those requests. And we can also have those scale across a cluster like we might see with an orchestrator with Kubernetes or Swarm. So these are very powerful concepts. And as you've seen through these use cases, they're very powerful for developers. They're very powerful for automation engineers, but certainly also very powerful for production operations. And this is why this is such a disruptive technology, is because you can really come at this from many different directions. We do many engagements as BoxBoat where we're just working with the products team, or where we're just working with development. But inevitably, we end up kind of crossing the divide and begin working with the other teams because they find the value. But it really touches the full spectrum of the software development lifecycle. So I wanted to talk and kind of close with a case study that BoxBoat ourselves worked on, and it was a large healthcare company. This is I have them listed as a Fortune 300. I think they're even bigger than that. But they came to us, needing more efficiency out of their software development lifecycle. They were having a lot of difficulty trying to grasp, what are we going to do with this giant monolithic application that we've created? We really need to speed up deployment times. We need to increase our competitiveness, and the code base was just growing exponentially, and they knew that they needed a more modern way to do things. They were also struggling with scale, so having peak load at certain times or certain times of the season with this one particular application was turning into a problem. And they came to us knowing that we were containerization experts and continuous integration experts to help them figure out that process. So what we did was we architected a solution for them. We containerized one of their legacy, what we deem as legacy, one of their older monolithic 3-tier web applications. We stood up a new containerized orchestrated environment for them. In this case, it was Docker EE. And we also built a continuous integration process and pipelines around that deployment. What this did is that it reduced their new application instance provisioning time literally from hours to minutes. That's not a sales pitch I am a tech guy, and it really can drastically improve your deployment from that type of scale. So previously they had archaic deployment processes, and they were deploying an entire monolith. Even just the compilation of that application would take a very long time. Pushing it through the process and getting it out to an environment, making sure that everyone was okay with moving to that environment, certainly took hours. Once we broke that apart, Dockerized it, we didn't even break this application apart that much. We Dockerized it, put in an automated process in place. Containers now were being pushed automatically through the system with code check-ins automatically. Docker shares the underlying file system across multiple images as they're pushed through the process, so you're not having to push the entire container image as you go through each environment. So now their provisioning time decreased drastically. They also increased in scalability, because now that they had containers and they had an orchestration framework in Docker EE, and now they're talking moving Kubernetes, which is in EE as well. They now have the ability to say, oh, we're peaking on this one service. Let's scale this up, and it can be, and it is as easy as that. So really, overall, we're just talking about utilization. This is now so much more efficient for this customer to deploy code, staying more competitive, and decreasing costs as well, because now their infrastructure is much more better utilized. When we're talking previously, we're running VMs on a machine, and we got a lot more efficiency out of that machine with VMs. If you're now running containers on a single machine, your efficiency is now going up that much more, maybe a factor of 10. You're no longer having to store that underlying operating system, as well as the fact that containers share their underlying file infrastructure. This was a huge win for them, a huge win for BoxBoat. We're still actually carrying forward and knocking out more applications for them. But you can see how containerization is very powerful for them, and certainly for the enterprise. It certainly doesn't even apply just to healthcare. All industries have been affected by this breakthrough technology. Certainly finance and healthcare and others that are stuck, so to speak, and kind of what to do moving forward with some of their older systems, and especially in the newer greenfield applications where they can immediately start taking advantage of some of the newer architectures that can be built with containerization. So thank you. Thanks for listening to me. I would love to take some questions after this, but I'm going to go ahead and pass it over to Brent to talk to how dotCMS has begun containerizing their app so that they can take advantages of a lot of the use cases that I just spelled out. So thank you guys very much.
All right, let's get started with our sneak peek into dotCMS running inside of Docker. What we want to cover today is talk about our plans for supporting dotCMS running in Docker going forward. Then we want to give you a demo of where things stand right now with dotCMS running in Docker. And then we'll save some time at the end to answer any questions you might have about dotCMS running inside of containers. So as it relates to support for Docker, we will start officially supporting dotCMS running in Docker in the 5.x series. Unfortunately, we don't have any more specific time frame than that. What does that mean? Well, what that means is we'll actually release Docker images with every release. So right now, for example, we release zip files and tar files of the release. We'll also add Docker images. Every release will also include a Docker Compose file. Now, this is our current thinking and subject to change, but our current thinking is to provide the reference implementation in Docker Swarm, with the idea being that the other orchestrators are more sophisticated and have more functionality than Docker Swarm. So if the reference implementation is able to document the components and how they interact together, that it'd be easy to take a reference implementation that's in a Docker Compose file and make that work in the orchestrator of your choice. Which brings us to the next point. We will support the official dotCMS Docker images in the orchestrator of your choice. So whether you're using Kubernetes, Mesos, some specific, like AWS has like 3 different ways you can do containers, we will support our images running in the orchestrator of your choice. When we get to the demo, I kind of want to just show you our starting state. Basically, just 7 computers with a file share. And I'm I'm doing this at Amazon just because that's what's easiest for me. This could work in Azure, Google Cloud, DigitalOcean. If you happen to have 7 network computers underneath of your desk, it can work there too, okay? Just basically 7 servers. I have a Docker Swarm set up with 3 managers, 4 working nodes, and we have one of the workers is a little special. We'll talk about him in a little bit. What we'll do though from the starting state is we'll deploy one instance of dotCMS. Now if you're familiar with dotCMS, you'll see a couple of components here that maybe you're not familiar with. First of all is Trafic. That's just a load balancer that we're using for sticky sessions. But then also you notice instead of just Dockerizing the monolithic dotCMS, what we've done is we split out a couple of components. Elasticsearch, for example, we've externalized that into a separate component so that if you have a site, for example, we see some clients that have sites that have a lot of content pulls where they're doing lots of Elasticsearch queries, multiple Elasticsearch queries per page. And so when their site is under heavy load, their site is slow to respond, not because dotCMS is taxed, but because they have a number of Elasticsearch queries that have kind of backed up in a queue. Okay, and so in that case, what this allows you to do is to scale each of these components individually. So if you need more Elasticsearch capabilities, you can add some Elasticsearch instances. You don't have to add a whole nother dotCMS instance. Just add the component that you're bottlenecked on. So same thing with cache. We're using the Hazelcast cache provider here. And we split that into its own component as well. Now out here to the right, you see our special little static guy. He has Elasticsearch, and then he'll have Elasticsearch and the database running on him. Really just handling data persistence. So for example, if we take all the containers down, we don't want to lose our index. And so this static worker, he's just a worker that's been labeled in a special way and is actually persisting his data so that on system restarts, etc., there's no need to rebuild your index. And then what we'll do is we'll go from a single instance and we'll scale it up actually in a couple of steps. But what we'll actually basically do is scale up to a full dotCMS cluster. We'll have 3 instances of dotCMS, multiple caching instances, multiple Elasticsearch instances, just to show how easy it is to scale up in this type of environment. Okay, let's jump into our demo. First thing I want to do as we jump into the demo is kind of show the initial status of the swarm as we talked about. So if I look at the nodes here, we'll see that there's 7 nodes, 7 servers. And as we talked about, we have 3 managers. These bottom 3 are managers. The other 4 are worker nodes, as we discussed. Now, just to show you that nothing else is going on, I can look at the services. You see that there's no services running at this point. So what we want to do is we want to start our service, which we're going to call demo, and it's going to read our Docker Compose file basically, create the necessary networks and services to bring that up. All right, so now if we look, let's look and see what services are running now. And we'll see that it started all these services. So mainly what we're looking at here is this replica column. This back number is the number that our Docker Compose file, the number of instances, or what they call replicas, we're supposed to have. The first number is how many we have. So we see that all of our services have been set up. So now what I want to do is I want to come up here and I want to just check the front end, make sure that it's responding. So those of you who aren't familiar with dotCMS, we come with a starter site just as an example of different types of content and things. So what I want to do here is I'm just going to browse around a couple of pages, make sure things get loaded into the cache. Okay, so it's responding to front-end traffic. So what I'd like to do now is let's look at Visualizer. This is just an example application that Docker provides. I'm just have it here for demo purposes. I would not recommend running this in production, but it shows us kind of where the containers ended up. So you kind of see this time, Docker Swarm really spread things out very evenly. We have our static node here with our database and the static Elasticsearch. We have Hazelcast on this worker, Elasticsearch on this worker. Then we have three managers. One's running the visualizer, which is just this tool that we're looking at now. And Man Center is on another manager. That's just a tool from Hazelcast that lets us look into the cache and have some visibility there. And then the other manager is running Trafic, which is the load balancer we briefly mentioned earlier. And then the other worker is actually running the dotCMS instance itself. So now what I'd like to do is I'd like to log into what we call the back end, our admin interface. And then what I want to do is just come over here and show you a couple things in the configuration area. One, I want to go over to licensing and show you that out of our license pack, one server came up, it grabbed a license. And then I want to go over to the network tab, which is going to show that currently we have one .cms node that's up and running. And we get some extra information over here. Obviously, we have one cache node. So this is the one Hazelcast node that started up. So it takes us to the Elasticsearch area. Now it says we have three nodes. The reason for that is we have .cms, that has Elasticsearch embedded. We have the static Elasticsearch instance, and then we have the one dynamic instance that we started up. So that's a total of three Elasticsearch nodes. So now what I'd like to do is go back over to our command prompt. And then I want to scale up a couple of services so we can see what that looks like. So what I'm going to do is scale up Hazelcast. If you look up above here, we see Hazelcast had one replica before. We're saying, no, let's set that to 2. So it's going to add an additional replica there for Hazelcast. And then let's do something similar for Elasticsearch. And so all these commands have done is said, take this existing service, change the number of replicas to this number. That can be an increase or a decrease. In this case, they were both increases. So now let's go to the visualizer and look and see what this looks like. So if you remember before, we had one on each of these servers here. We see now we have an extra Elasticsearch. We have one here and one here, as well as the static one that we have over here. And then as it relates to Hazelcast, we have Hazelcast here, and then the new instance got put on this worker over here. So now if we refresh our network tab, what we'll see is we now have 2 Hazelcast caching nodes. And we come down here, we have a total of 4 nodes, which is our 2 dynamic nodes, our static node, and .cms. And so we were able to scale up those services independently of .cms. Okay, now what I'd like to do is come over here and I'd like to scale up the actual .cms instance. You know, basically spin up 2 more .cms's. And then, just for good measure, I'm going to also scale up the Elasticsearch to a total of 4 replicas. So now just kind of, let's look at the services here. So we'll see here we have 3 of 3 .cms's, we have 4 of 4 Elasticsearches, and then let's look at the visualizer. And so you'll see these workers got some more work added to them. So if you look at Elasticsearch, we have a total of 4 dynamic Elasticsearches. They're all color-coded here. And then if we look at .cms, one is here and one is here. And the third one is over here. All right, so if we come over here now, and if we go to the licensing tab, we'll see there are 3 .cms servers. Each one of them has grabbed its own license. And we'll come over here to the network tab, and it'll take a minute to refresh. And there we see have 3 .cms nodes. Still have the 2 Hazelcast containers. And now we have a total of 8 Elasticsearch nodes. The 3 .cms's, the 4 dynamic, and the 1 static. Well, there we have it. .cms running and scaling in Docker. If you've ever set up .cms clusters, you know it does not get much easier than this. This also sets things up for easier automated deployments, which will make continuous delivery more attainable. So just to wrap up, dotCMS is committed to supporting containers starting in the 5.x series. We demonstrated dotCMS running in Docker. And then lastly, I just encourage you, come to boot camp. We have boot camp down in Miami. We're going to have some more Docker presentations there. We'll also have more timeline and product roadmap details to share with you at that time. All right, with that, Robert, I will turn it back over to you for question and answers.
Fantastic. Good stuff, guys. It was really nice. So let's go through some of the Q&A, and just remember, like we said earlier, if you want to follow any of this on Twitter, use the hashtag ContainersWebinar, and there are our Twitter handles as well for that. And let's see, we've got a bunch of questions coming in right now. Let me start this thing off here. So looks like the first one is to dotCMS and Brent. When can I get a copy of the Docker's images?
Okay, well, that's a great question. We are there's a lot that needs to happen here internally, but our current plan is to release a beta version of the Docker images either right before or during boot camp, which is the beginning of May, so May 2nd to May 4th. So just about a month away. We're going to do the best we can to try to get a beta version of those released. We don't have a timeline yet of the final versions when they'll be released.
Great, thank you. All right, the next question is for BoxBoat and Will. Do Docker containers package up the entire operating system?
Hey, that's a great question. As we reviewed a little bit earlier, they don't package up the entire operating system, just the file system. What this allows them to do is be very portable across all systems, as long as the kernel is supported, which most are. So you get a much lighter weight single artifact that you can deploy across a broad range of supported systems.
Excellent. Back to Will again. From an infrastructure standpoint, what do I need to run Docker?
Yeah, that's very important to get going. Docker is actually just a very lightweight client server architecture. It does install out of the most popular repositories, Yum, apt, Git. You can also pull it from other sources. It is an open source project, but that's it. That's it, really. It's a single installation, and once you get it going, that is all you need.
Excellent. Will is the popular one here today. Can I run a database in a container?
One of our most asked questions, and the answer is pretty clear. You absolutely can. Containers or data stored within the container itself should be ephemeral. It should be able to go away. So if you run a database in a container, it's going to run on that host operating system just as if it was not in a container. So there's no reason you couldn't. You just need to make sure that you're storing your persistent data to what is called a Docker volume or some other external store that's mounted to the container. But we see this model quite a bit, and especially with distributed databases where those like to scale. So yeah, absolutely.
Excellent. Let's get Brent involved again here. Will dotCMS's performance be better when running on Docker?
Well, I wouldn't necessarily say it's better. There's nothing about Docker that is inherent overhead as far as CPU or memory, because it's using, the same kernel and operating system. So there's very little overhead there. We don't think it'll necessarily run better, but what it will do is, because we are breaking up the program into more scalable parts, there'll be more ways to tune it. So for example, we'll be able to address the specific area that has bottlenecks and scale up that area. So we believe it'll be much more tunable, and I think for medium to larger size loads, you'd be able to work with us, and I think we can optimize something that will perform, probably better than current implementation.
Okay. Here's one for you, Will, and I feel comfortable asking this now that I can pronounce Kubernetes. But when would I use Kubernetes?
Yeah, so Kubernetes has gotten a lot of fanfare lately. It started as a white paper out of Google, and the open source community has grabbed a hold of it and run with it. It is the go-to orchestrator, container orchestrator for most shops nowadays because of its flexibility and power. I've been a firm implementer of Docker's implementation in Swarm. It actually ships out of the box with Docker, which makes it very easy and very quick to deploy. Kubernetes needs a little bit more configuration. You need a bit more experience with it. But in my experience and in BoxBoat's experience, it's a give and take between either orchestrator and others as well. One that Brent mentioned with Mesos, and Mesos itself even runs Kubernetes. But certainly it really comes down to a personal preference. I'm a big fan of Swarm, but also of Kubernetes. So I answered your question, but didn't specifically answer it. I apologize. I'll stay on the line there.
Good deal, Will. Let's see here, one for dotCMS and Brent. If we currently host dotCMS ourselves, can you give us an idea, is it going to be cheaper or more expensive to host containerized versus the way we host now?
Okay, so really hard to answer that question in a definitive way because each case is going to be a little bit different because there's a lot of factors involved. So for example, how are you hosting it currently? What are your costs? If you're going to go with Docker, the Dockerized version, how are you going to host that? I mean, even within Amazon, they have 3 different ways of hosting that with 3 different pricing models. So hard to answer that in a definitive way, but couple things to think about there. One is, again, if you're a medium to larger scale, there's a possibility of savings because you don't have to replicate a whole entire version of dotCMS, instance of dotCMS. You can scale individual smaller parts. The other thing that, which Will really kind of talked to in his presentation, is there's a lot of value add moving to Docker. It makes it much easier to deploy into your staging or UAT environments as well as in production. So there's a lot of cost savings there as well. But really hard to talk in the abstract about that question. But be glad to interact with clients later, specifically about their situation.
Awesome. Yeah, these are really good questions, and getting even more a little specific here. Brent, back to you specifically around dotCMS. So when you are scaling up clones of your dotCMS instances, is your load balancer automatically handling balancing traffic between your instances? Or do you need to make any changes to the load balancer first? You want to take a stab at that?
Sure. So one of the reasons we went with Trafic is because if you remember the slide where it was running on the manager node, one of the reasons it runs on the manager node is because it connects to the Docker socket where it can monitor what happens. And so when a new Docker container gets deployed, Trafic monitors that, notices that, and is looking for specific types of containers, in this case dotCMS, and so it automatically detects that and adds it to its pool of instances to load balance to. So basically, it figures it out dynamically at runtime to add that instance.
Awesome. Jumping ahead, but I just do want to answer this one. Yes, we will be sharing this presentation and all the slides to everyone who's at attendance today. So I want to make sure that came out. Here's a jump ball. Is there any way to change the default registry setting to reflect what our internal settings are?
I assume by registry there, I assume we're talking about the Docker image registry.
I believe so, but that's all I have to go with right now.
Sure.
Absolutely.
Okay. So yeah, so that's something that you totally can do. Whether you're pointing to one internal or, for example, AWS has their own registry that you can run. That's totally something you can set up on your Swarm as part of the configuration of your environment. By default, of course, the hub.docker.com is the default, but that can be a different one of your choosing.
Okay, Brent, you're getting more and more popular by the question here. Speaking of cost savings on individual parts, are there any costs for each non-Docker part? Elasticsearch, for example.
I guess it depends what you're talking about cost here. I'm assuming we're talking about deployment cost. Right. So from our standpoint, I'm not aware of any plans to charge separately, for the different containers. All the containers would be included with your licensing of dotCMS. As far as deployment, kind of comes down to, again, how you're deploying it. So for example, AWS, some of their ways they're going to charge you, per container, or how long that container's up. If you're deploying it yourself on your own infrastructure, it's whatever the cost of the infrastructure is, but there's no specific cost from our standpoint connected to any of these options.
Right.
Now, Hazelcast is an open source provider, for example. If you wanted to go beyond, for example, 2 nodes in Hazelcast and use Man Center, you'd have to get into a licensing situation there, that kind of thing. But specifically from our standpoint, no, there's no cost specifically tied to these individual Docker images.
Right. Ryan followed up with that actually, and more specifically wanted to talk about licensing costs. And Ryan, that is a version 5 that we'd be happy to discuss with you. We can take that offline and get you some information on that. Okay. Let's see here. Okay. And it looks like, and folks, keep them coming, but feel free, looks like we've come to the end, and I've got one last one. With Docker, it's easier to deploy to local UAT production. So will this replace push publishing, or how is content changes, or how are content changes handled? Excuse me.
Right, so this will not replace push publishing, right? So push publishing is about taking content from an authoring instance, for example, and pushing it into another environment. Now, today you do have the option, right, of if you wanted to back up the database and the assets and the index and move that to another machine, you could do that. So in a sense, if that's what you're interested in doing, Docker could potentially make that easier for you to do, but it's in no way a replacement for the real push publishing functionality.
Okay, like I said earlier, thank you so much for those questions. That was a really good, thought-provoking presentation by both speakers today.